Thank you again for joining us. Today's presentation will be on cold form steel structures. The presenter is James Graham with National Technical Sales Business Development with Imperial Building Products. So I'll stop there because we already used and apologize for technical issues that we had. So I'll stop here. I'll leave the rest of the introduction to James and also this topic that he's going to talk about. Okay, thank you.
I'm going to go through the presentations as the things we manufacture. I want to thank Tyler and Ali for making this possible for the students. Hopefully it's going to be informative, and we'll go from there. So I'm going to start with the company overview, what we do, the products we manufacture. I'm going to go through some manufacturing processes, how it's galvanized and everything, cold form steel. I'm going to go into some technical data, where the products you can get the technical information from. I'm going to go through some system profiles, some construction guidelines, and then at the end, when time permits, hopefully we can have a group discussion or can answer some questions at that time. You might want to put your questions in the chat if you want, and then we can get to that at the end. I've got a lot of slides to go through here, so want to go through that, and then we'll have some question periods after. So the company profile, IBP is a coast-to-coast national steel stud manufacturer, and we have branch offices across Canada. IBP was recently acquired by CGC, which is a Canadian gypsum wallboard and ceiling products. We manufacture all these products and accessories. I'm going to go through it. Proprietary products, the galvanizing process. Steel is hot rolled from recycled material. Then it goes through a cold rolled reduction process. So you see in the middle of the screen there, that screen there. And then it's hot dip galvanized, various galvanizing from G40, which is Z120, to G90, Z275. I'll get into those a little bit later on. Once the galvanizing is done, it's rolled into master coils, and the master coils can weigh anywhere up to 45,000 pounds. The master coils are then sent to the slitting warehouse, where it's slit to the various sizes that you need, different profiles that we make. It's slid in the warehouse and it's trucked back to our warehouse, where we actually produce the final products. As you can see here, the hot dip galvanizing coating on the left-hand side, you'll see it's G40, G60, G90. Those are the three most common ones that we use. The G40 is used, I call it G40, G60, G90, but then the proper way of calling it is the thickness in the very right-hand side there, 018, 025, and 039, or Z120, Z180, and Z275 is the coatings designated that you use. The G40 is used for your non-load bearing drywall steel stud interior partition walls. The G60 is used for your structural, anywhere your 18 gauge or 43 mil and up. The G90 is, it wasn't very commonly used before, but it's used commonly now. It's used for exterior, where you're using exterior walls. You have more moisture and stuff like that coming in there. So if you want a thicker coating, you can use a G90 coating. But G60 is, as you can see, G60, the lifespan is 150 years lifespan on that. So G60 is just as good. How the C-section is done, you have your web, you have your flange, and your lip. You'll see on the left-hand side, on this side here, the thicknesses. So 18 is your 25 gauge, which is your drywall steel stud. So on your left-hand side, you'll see all the designation, and then on your very right-hand side, those are the old way of calling it. So if it's a 43 mil, we used to call it 18 gauge. So some of you probably are familiar with gauges or whatever, but the proper way of calling is through the on the left-hand side, 43, 54, 68 mil. Okay. The designation, this is how it's called up on the drawings. the old-fashioned way of calling 6-inch, inch and 5/8 by 18 gauge stud or 16 gauge stud. Now the proper way of calling it is 600 S 162/54, meaning the 600 is your 6-inch steel stud. If it was 3 5/8, it'll be 362. Okay, the S in the middle here is your stud. If it's a track, it'll be called a T. And we have a mega joist, and we would call it M over there. 162 is your flange thickness. So it'll be 125 if it's inch and a quarter flange. Your 54 is your mill thickness. So that's like a 16 gauge steel stud. Okay. So Imperial Building Products is a registered member, fabricator of Canadian Sheet Steel Building Institute, which is the acronym is CSSBI. CSSBI actually has the main body where all the technical information you will find. You can visit their website at cssbi.ca and you can download all the technical information from there. Design guidelines, helpful hints, how to pick a member, and all the section properties, everything's on there. Okay, or simply you can call one of our branches and visit our website also. Okay. The reference documents, it's maybe hard to read over there, but the reference documents, the ASTM, American Society for Testing and Material, it's the ASTM 792 is your zinc coated. Your ASTM 645 is for your non-load bearing, non-structural framing, your drywall steel studs. Your ASTM 955 is for your structural load bearing steel studs, so anywhere from 43 mil and up. And also the reference documents is CSA standard, Canadian Standard Association. So CSA CAN S136, you can find all the design guidelines and follow those guidelines. The AISI, the American Institute of Steel, S220 is your non-structural steel studs, again, for the drywall. The S240 is for the structural. The ICC is your International Code Council, the NRC, National Research Council, and also the National Building Code of Canada. And those are your references. Okay. So the non-load bearing steel stud, like I said, is 18 mil, or as I call it, 25 gauge. It's available in inch and 5/8 width, up to 8 inches. It's used mainly for multifamily, residential, high-rise buildings. You won't see wood in your high-rise buildings because it's got to be non-combustible. So this is where you see most of the infill steel studs are made with this 18 mil studs. Okay. The non-load bearing compared to or advantages of LSF with wood frame. Steel would not rot, shrink, swell, split, or warp. It's also non-combustible, sorry, like I said. Steel is consistent. It's very durable. Steel is supplied to the exact length, so we cut to the exact length, so you have less wastage in your job sites, on your project. It is pre-punched at every 2 feet on center. We have the knockouts at every 2 feet on center, so you can run all your surfaces through there, such as your bridging for your structure. And it's also it's 98% recyclable, so it's very cost effective. Okay. Some of the accessory products, a resilient channel, which is also you may have heard, it's called res bar or sound bar. Some people call it. It is for sound transmission. So they use this. You can use it on the walls, on the ceilings, so to get a better STC rating of your walls and ceiling. The 7/8 furring channel also, it's a hat shape, so a lot of people call it a hat section. And it's used for your walls, your ceiling, your furring, if you're furring out your masonry walls and stuff like that, and it's more rigid. It's used for, we have 2 different gauges, 18 mil and 33 mil. So whatever you need and whatever's designed for, we can actually produce those. Just back to your res bar, I'm just showing how it is attached actually. As you can see in these areas here, they do not touch the ceiling or the wall. So you don't have that penetration going through for your studs in your ceiling. So your SDC rating is much better. And it's also the way to attach it. That lip is attached here, but then your drywall is attached over here and over here. So it's not touching the steel studs. So that's where you get the sound transmission and a better SDC rating. Your carrying channel, 1.5-inch carrying channel, that's used for bridging or bracing. It's a lot of times for your structural, well, all the times for your structural use with your bridging clips also, which I'll get into the next slide here. The Z bar, we actually make many sizes of Z bars. It's used for your rigid insulation, and also different types of, if you want to furrow the wall or something like that, you can call up a Z bar anywhere from 1 inch. I mean, I make up to 1 inch to 8 inches in width, using different things. Your flat stock bridging also, you can use this as your flat stock bridging. A lot of times, if you're using it for a backing, if you got cabinets hanging on your walls, any fixtures, shelves, or hand railings, you can use these flat stock bridging. They come in custom sizes. We actually cut it right from the slit coil that we have, so you can order whatever size you want, whatever widths you want, and then the lengths, whatever lengths you want. We can actually custom cut those and send to the job site. Okay. Your wind load stands for the wind pressure. It's also an infill for the structural steel beams. As you can see, the cross section over there, it's an infill for your steel structure. The flanges are anywhere from 1.25 to 1.6. 1.25 is most common for wind load bearing. But if you want a structural exterior wall, you can ask for 1.5 flanges also. Okay. So what comprises of this curtain wall? You have your studs. I'm sorry. You have your studs. You have your deflection track on the top. You have your carrying channels at every 4 feet on center, and it's braced with the bridging clips. And then you have the bottom track that comprises of your wall for your wall section. Here's a picture of the deflection track. This is the most common deflection track used in the market now. It's called a slotted track. As you can see on the left-hand side picture, there's a lot of slots in those tracks. The old-fashioned way of doing was your regular track and a deep track, but that's the old-fashioned way. No one actually uses that, but sometimes the engineer would want to use it. What they call it a slip track is they want the white on there. But the most common way of using it now is we use this slotted track these days. Okay. There's a bunch of different clips they can use also for your deflection that I'm showing here. On the double track here, that's what I talked about, your slip track. That's the old-fashioned way of doing your deflection. On the right side in the bottom there, that's the multi-slotted track. That's the most common way of doing your deflections now in the walls. The common bridging systems, the number one is the most common way, where you're running your bridging channel and using your clips. These clips over here, actually, it doesn't have to be on that flat surface. Some of the engineers want to put it in the inside of the stud. Either way, there's not much difference. Which if you put it on the flat surface or in the inside surface. Number two is your flat stock bridging. You can use flat stock bridging for your structural rotation of the deck, or the notch channel. It's not very common, but we do carry the notch channel. You can use the notch channel also for your studs. This is the bridge ready tab stud that I've talked about earlier that we have. What we have here is you'll see this little tab over here. It's not punched right through. It's punched, but it's left in place there. So on a job site, when you go on a job site, all you have to do is just flip that tongue down, and then you run your carrying channel through. So you're actually saving a couple of things. You're saving labor, so you're not having those clips in there, and you're also saving on the material by not having the clips in there. So these are in every stud, So you can actually screw that carrying channel right to that tongue there. Okay. The next slide is our Viper V20 stud, which again, it's used very commonly used for hospitals, schools where there's more abuse required in there, hallways and stuff like that. There's the beds and stuff like that going through the hospital and stuff like that. This is more rigid. It's the STC rating on this is just as well, just as good as your 18 mil stud, 25 gauge. STC of 50 you can get. Strength wise is just as good as your 20 gauge or your 33 mil. This is 0.019. So it's in between 20 gauge and 25 gauge. So this is more commonly used where more abuse is on the projects. And we actually manufacture this in Vancouver. Here's what it looks like. So you can see, and this steel here, the Viper V20 is made from a harder steel. It's KSI. The KSI on is 70 KSI. The regular drywall steel stud is 33 KSI. Your structural steel studs is 50 KSI. So this one here is 70 KSI steel. It's a harder steel. You can see they're knurling on the edges. So when you're penetrating the screws are not riding in that web there, or sorry, the flange there. So and then the rib in the middle there, that makes it even stronger. Actually, this rib in the middle there, that makes it very, very rigid. I do have some samples. So you guys are welcome to touch and feel the samples afterwards if you want. Your combined load bearing steel studs used for wind load or your load bearing steel studs. The minimum flange thickness is 1.5 for your load bearing steel studs. These steel studs, if they're typical, they could be actually manufactured right on in the shop, and then you can actually build these panels and ship it right to the job site, or you can stick frame these. It's more common to use it in a controlled environment where you actually use a jig to actually compress the steel studs, so you don't have the deflection on there. You don't want deflection on a load bearing steel stud. So I'll get in the next slide. I think I'll show you. So here's the minimum gap that you have to have in your load bearing steel stud. As you can see, 1/8 is the maximum gap that you want on your load bearing steel stud, and you don't want something like this where it will deflect. So your load bearing steel studs, your 43 mil and up, has to be done that way. So most common way of doing it is in a shop where it's controlled and it's compressed, and then you can screw it down. Okay. The headers, you can actually build up headers, lintels, or posts with a C-section. This is one way of showing it, but you could also do a box section with toe to toe. This is back to back. So most of the time, if you're using back to back, you can use your if you see this section here is back to back, and you can cap it with a track. So it becomes a box. You cap it with a track, or you can do toe to toe. I like this way here because you're using screws to screw everything together. If you're doing toe to toe, most of the time the toes you have to weld those in because you can't really screw those together. Okay. Our Delta stud, the one that I showed over here, has got a lot of these perforations in here. So these Delta stud is good for your thermal value also, because it's not a solid section. It's got all those holes punched in there, so you don't have your cold and your hot transfer going right through. Also, it's a better STC rating because you don't have that solid section. The STC rating is much higher. Okay, these are also not for non-load bearing. It's not for your drywall interior studs. It's 20 gauge is the minimum that we do. It's mostly used for your load bearing steel studs. So anywhere from 20 gauge to 14 gauge, which is 68 mil. Okay, and galvanized at G60 again. These panels, again, it could be panelized in a shop, controlled in a shop where everything is compressed and is tight, as you can see. They make in the shop and they truck right to the job site, and then it's ready to install in the job site, and it goes really fast this way. Okay. Delta stud has a greater combined loading compared to your regular C-section, anywhere up to about 20%. In some of the cases, significant reduction in thermal loss, like I said. 3 5/8 is the minimum that we do, up to 8 inches width. And the flange size, it could vary. If you want a bigger flange size, it goes anywhere from 1 5/8 to 3-inch flange if you want a bigger flange. These are pre-cut. The holes are aligned. We have engineering load tables right on our website. So the stamped opening makes it easy to run a lot of the services. As you can see, you can run your electrical, your plumbing, a lot of other service right through those webs there. Good thing with you guys here, if you go into a job site, I'm not sure if you've been to any job site or not, but if you go to a job site, you'll see these drywallers or other trades coming behind you and cutting the studs because they got to run the plumbing service, they got to run the electrical service, and now it's a headache for you guys saying that, oh, that stud is no good now. I have to beef it up somehow, put in the stud there or do something, put a header there or something. Here with this stud here, when we came up with this Delta stud, it's sort of a no-brainer for the plumbers and electricians because all the holes are punched for you there. You can run most of your services right through the walls here. Okay, and then you can use your flat strap bridging, or you can actually use a carrying channel through those webs with a clip on there, and then just screw it in place. Okay. As you can see, the holes are pre-punched and they line up, so you can run your services through there easily. Okay. And our next one is Mega Joist, which is and it goes anywhere from 8 inches deep to 14 inches deep, and 20 gauge again, 033 up to 14 gauge, 68 mil, galvanized again with G60. This is mostly used in the interiors for your floor systems. You can use plywood on top of it on a residential job, or if it's a commercial job, all you do is use a 1.5 inch Q deck on top, and you pour concrete on it for your commercial use. These joists here will span up to 30 feet, depending on the depth. If you're using say a 14-inch deep joist, 68 mil, you can span up to 30 feet, clear span with these joists. Again, the holes are pre-punched, so you can route a lot of the services, some small ducts right through those holes. It's got a good SDC, a better SDC rating than your solid section. I've used these products on many types of jobs, single family homes, condos, schools, hospitals, anywhere you can use these. Okay. As you can see, it's a very simple system. It's easily installed. At the ends, you can either use your hat rack to cap the ends. It sits in between the track. It sits at the ends, or you can use joist hangers. If you're using a structural steel beam, you would use a joist hanger, and then the joist will sit inside the joist hanger, and then you could just install those. Okay. These are installed anywhere from 12 to 16 inches or 24 inches on center, depending on your design. Okay. As you can see, the service holes, how the small ducts are passed through those openings. Your sprinkler pipes, your hot and cold water, your electrical, everything could be passed through there. So you're not having a bulkhead. You don't have to worry about dropping the ceiling to create a bulkhead. You can actually run quite a bit of service right through those holes there. Okay. Our next product is called Ultrabond. Ultrabond is a composite floor system. It's a 24-inch wide section. From bottom of the flute here to the bottom of the flute here is 24 inches, and it's 8 inches deep, constant. It's the depth is 8 inches, and these are actually, there's a male and a female, so a male and female overlap each other. And then you just install this in place with a side lap washer, and it takes very minimum rebar. The only rebar that you required is in the flutes. As you can see, these flutes here, the rebar in the bottom here. Hopefully, you can see that rebar there. And every flute has a rebar in there. Okay, and on top you'll see this. This is mesh. This is not a structural requirement. This is just for anti-crack. Okay, so because of the thin slab, we use that mesh so the slab doesn't crack. We have tested this for fire rating, and you can get up to a 2-hour fire rating as a bare assembly, meaning you don't have to have drywall underneath. It's been tested with 3 inches of concrete to get a 2-hour. 2.5 inches will give you hour and a half as a bare assembly. If you want to put a drywall underneath, all you need is 2.5 inches of concrete topping plus 1 layer of 5/8 drywall, and then that's your 2 hour. So all these have been tested, and I'll show you that the testing in a later slide here. So now you say, why would you use composite floor system? I'm going to show you in a couple of slides here that it's going to save you some time. It's going to save you money on material, and it is a winning performance. So Ultrabond, the advantages of Ultrabond, it's a safe working platform. It's unshored during construction, so you don't have to worry about shoring. You can actually do these. It will span up to 33 feet, so you can have the deck spanning up to 33 feet without any shores. The only time you need shores is when you're pouring concrete. Wet concrete is so heavy, you need shores for that. So, and then you can remove the shores after 75% of the strength, which is usually the next day. It's very fast. You can install about 5,000 square feet a day. And it's compatible with all types of structures. I've used these in schools. Schools are great because, as you can see at this room over here, what I would do is I would span this direction here, the long direction. So it will span up to 33 feet. Most of the classrooms, like the high school classrooms, most of them are 25 to 27 feet wide. So I would span from outside wall to the corridor wall. And in the corridor walls, I would use 1.5 inch deck, a smaller deck, to gain more headroom space in there, so you can run your sprinkler pipes and everything through there. So again, you're not creating bulkheads and stuff like that. You have a flat ceiling. Okay, I'll show you in a couple of slides here. So the Ultrabond, as I said, it's you're using 70% less rebar. As you can see on your left-hand side here, as you can see on your left-hand side here, it's very loaded, or your cast-in-place slab here. The Ultrabond here, like I said, the rebar is only at 2 feet on center in these troughs here, and the top is just your regular 6/6 mesh for your anti-crack. Okay. Your shoring, again, 65% less shoring compared to your conventional cast-in-place slab. As you can see, there's a whole bunch of shoring over here. So these shorings are staying in place until the concrete cures, and then your other trades can come afterwards and do a lot of the work. With the Ultrabond system, most of the time, all you have is one row of shoring here. The Ultrabond will span about 10 to 14 feet, depending on the gauge. We have 2 different gauges, 20 gauge and 18 gauge. So it will span up to 14 feet without a shore. So most of the times you're only using one row of shore in the middle. Your other trades, your plumbers, electricians, all the other trades can come right behind. As soon as your deck is in place, they can come behind you and start putting their ducts in there, your electrical, your plumbing, everything services through there. So you're not wasting any time. It goes really fast. Okay. Material savings, again, because it's a thinner slab, you're using about 40% less concrete compared to your 7-inch conventional cast-in-place slab. Okay. Like I said, it's got a fire rating, unprotected fire rating with 2.5 inches of concrete, and 2R with 3 inches. And it's got a good STC rating, minimum 56 STC rating, sound transmission class. And it's a high strength to weight ratio, this product. As you can see, the bottom flutes here, you can run your services through it. I'll show you in a different slide here, but you can run a lot of services through these openings here. Okay, it provides a fast track construction for the industry. Again, it creates a thin, high effects composite floor system. Again, you can use in any kinds of structures. I have used it in because we manufacture LSF products. We've used it in load bearing steel studs, but these decks they can sit on structural steel beams. It's concrete masonry. I've even used it on wood frame buildings, ICF walls, or even tilt up walls. Okay. As you can see, the services, you can run the services. This is showing one way, but then, like I said, you can punch the holes in here and run the services perpendicular to the deck, or you can run it parallel to the deck. You have about 17 inches by 8 inches of space in there to run your services, so smaller ducts can run right through there, so you're not creating bulkheads and stuff like that all over the place. The only thing you have to watch for, and the guidelines are in our load tables, the only thing you have to watch for is you have to have at least above the neutral axis for your rebar, so you're not touching your main rebar. So your main rebar is in the bottom here. As long as you're not cutting through that main rebar, you can punch the holes through there. You can punch, I think, up to about 5 inch, 5.5 inch holes in there. Okay. So I would recommend you do this before the concrete. As you can see, you see the lights coming through here. You do this before your concrete is poured. Otherwise, you're pouring through a thick section. So you do that. Put the sleeves in there, and then you can run all your services through there afterwards. Shoring again, it's left in place. You can remove the shoring after it reaches about 75% of your design strength, which is usually the next day you can actually remove the shorings. But multi-stories, you'll have to reshore. But if it's just a single floor, you can actually remove all the shorings and then carry on. An end bearing condition. So what I'm showing here is you'll see the slides. I'm showing the LSF, the steel studs on these, our Delta stud. But again, these can bear on any type of a wall structure. So you have at the ends here in the inside face, what we call it the enclosure. This also acts as a diaphragm for the deck, and keeps the concrete from flowing inside those flutes there. At the edge here, on the outside edge, we call it a perimeter trim. You may have heard some people call it the concrete edge form, but we call it perimeter trim. It just holds the concrete in place. You will see that this creates a bond beam over top of the steel stud, and these bond beams are created so you don't have to cluster your studs. So you can do the pre-panels in the shop, not thinking where these flutes are going to line up. It's not like your regular joist, open with steel joist, where it's a point loaded system that you have to cluster 2, 3, 4 studs depending on the weights that's going on there. It's a point loaded; those are point loaded system. The joists that are at 4 feet or 5 feet on center, you have to cluster your studs. You have to design for it. This way here, creating this bond beam at the ends there, it actually distributes the load equally to each of the studs. So it's going to be all single studs all over the place. And you do not have to line up with the stud. You can actually place these deck on the track because once the concrete is filled in there, it will distribute the load equally on the studs. Okay. This detail shows running perpendicular to the walls. Again, we're creating this bond beam over the steel studs. So you don't have to worry about your point loading there. If you want to create a beam inside your floor system, you can actually use a hat rack, the one that I talked about, a Z trim. This is an 8-inch Z trim over here that you can see that creates a bond beam right in the middle. Also, if you're wanting a fire separation for your rooms, you can have this fire separation with this concrete in there. Okay. Interior load bearing steel stud. Again, once again, you're seeing this bond beam over here. And I showed there's a couple of rebars over here, and that's as per design by the engineer. of record. If he wants to put a couple of, if there's a heavy load coming down from the floor above, if he wants to design this, he can put some rebar in here, design rebar, put some stirrups in there, and then create a beam that way. Okay. Again, this is this is a 6-inch load bearing steel stud, and the only bearing that we require is a couple of inches from both sides, and then when the concrete is poured, this is poured together. Your end closures are on the face of the stud here, so it creates a 6-inch wide bond beam over the walls. Change the direction. It doesn't have the deck doesn't have to only go one direction. You can actually change the direction on the load bearing steel stud. On the left hand side, you can see that you cut on a 45-degree angle. We actually supply end closures for different degree angles that you have the deck on, so you can cut those. They'll come cut square on the job site with extra lengths on it. And then on the job site, you can actually cut these. It's very easy to cut with a chop saw or your gas chop saw or something like that. Okay. Change the direction again on a load bearing steel stud. You can see is running parallel and perpendicular to the wall. This is a corridor situation. Your load bearing walls on a corridor situation. And again, on the right hand side, you'll see the Ultrabond deck sitting there. And on the left-hand side, it's what we're using is an 1.5-inch deck. So then it gives you another 5.5 inches of room, headroom over here. So when you put in your drywall underneath here, you have all these room to run your sprinkler pipes, your other ducts and stuff like that through the corridors right outside to the wall. Here's just a picture here. I mean, it could be either on a load bearing steel stud or I-beam, a structural steel I-beam. And this is the corridor over here with the 1.5-inch deck, and the Ultrabond is sitting in the bottom plate of this beam over here. So the drywall is finished on this bottom side here. Okay. Furring channel is placed at 24 inches on center at the bottom. I actually recommend that you put the furring channels before you pour the concrete. It also acts as a diaphragm for your deck, and also it's easier to screw into place when there's no concrete already in there. Otherwise, you probably come in with a Hilti shots and shooting those tracks into place. Okay. Fire rating. We had the fire test done at Intertech. Intertech is just similar to your ULC labs, and it's been tested under S101, ULC S101. So the same testing. It was just easier to get the testing done at Intertech and the laboratory in the US, and we got 1 hour, 1.5 hour, and 2 hour fire rating as a bare assembly. We did some other tests with drywall underneath there, and we found out that with 2.5 inches of concrete and 1 layer of 5/8 drywall, you can get up to 2 hour fire rating. Okay. Our other deck is similar to our Delta stud, but we call it a composite Delta stud. It's got a little S shape on the flange, which actually becomes a composite. And all you're using is 2 inches of concrete on the exterior. And with this system, then it was done with a tilt up your concrete walls. Here it is. It's a solid precast wall system while using about 60 to 70% less concrete than your regular tilt up walls. It's lighter, it's more solid, fast track system, easy to install. Okay. So I'm going to repeat myself here. Why cold form steel is benefits. It's fire resistant. It's non-combustible. Construction. It's durability, sustainability, structural performance, and it's cost effective. Acoustical performances, as I've shown. Steel framing again will not rot, warp, shrink, or crack or creep. And also, the major one is, as per wood, comparing with wood, it will not expand or contract when it has moisture contents in there. Less scrap on the job site. Like I said, we cut the length on the jobs on the shop and ship it out, so you don't have too much cutting on the job site. Steel is 90% recyclable. Shorter construction time means earlier occupancy for your buildings. So here's a little bit of comparison with wood, cold form steel, and your concrete and iron. As you can see, I'm showing wood as $35 to $45 a square foot. These are comparison done for a six-story buildings. In BC, most of the structures you can see they're building with six-story wood frame buildings, but it does not include, this price does not include your insurance cost on there. We've had quite a number of fires with the wood structures, and the insurance cost has just gone up. It's probably 4 or 5 times more than what it used to be. So if you include in the the insurance cost in there, I think steel stud construction makes it much more cheaper. Okay, so pound per pound, I don't see any other building materials as cost effective as cold form steel. Okay. Some of the services that we provide, we have fully engineered and tested systems, certified load tables, hard copies, or in the web. It's available. Design guidelines and cost saving options. So if you call one of our branches, we can actually work on a preliminary set of drawings that you have. We'll do a shop drawing. We'll show you how you can save, maybe switching the deck this way or that way, whatever, using less components, using less material, and how you can save time and money. Okay, it's just distributed across Canada. Everything is manufactured in Canada. We have over 1,000 installed projects completed with our proprietary systems, which is the 3 products that I went through. Okay. Lead credits, you can get lead credits with using the LSF products for your buildings. And here is an example of some of the lead points that you can get. So that's my end of the presentation. Thank you very much. And if we have any questions or any discussions, I'd be happy to answer them.